This session we will be covering the hands-on training on KiCAD tool. So anyone who is interested to learn KiCAD can follow the steps covered in this training. If you don't have KiCAD software pre-installed on your computer, you can go to Google and you can just download the KiCAD software from this link. So just type KiCAD download and go to this link here and hit on Windows if you are having Windows computer or whatever computer you are having, Windows operating system you are having, you can go and install. So here you can just hit on GitHub and it will start downloading the software. After installing, once you open the software, the interface will look like something like this. So in this training we will be covering the general introduction and the schematic and then the layout, and this first three items are going to be covered in one session, and rest items are going to be covered into the another session. This is going to be a series of sessions, so we'll see how much we can cover in this session. And now let us get started. Now let us go and create one project. So we will create one project. We'll go to file, create new project. So we'll go to training, and here we'll try to create project 1. So as soon as you create a project, you would see two things. First is PCB editor, second thing is schematic editor, which is already here. If you click here, it will open the same file, and if you click here, it will open this PCB editor file. So for now both are blank, there is no schematic. Once you open it, you can draw the schematic here. Similarly, once you open this guy, PCB editor view, so far there is no schematic and there is no layout, so both are blank. So now I will cover this both one by one. So the first thing goes to this guy, schematic editor. So in a schematic editor window, you will have this many options. It will look like this, the screen which you are seeing. This screen will show you the page, the number of page you are going to have in this schematic. Those all will be appear. So for now we have to make focus on this right sidebar where you have a select option here. Next is the highlight net. If you want to highlight any net, this we can use. Third is the very important option, which is add symbols. If you go and cover this one by one right now, you might not be able to enjoy it. So what we will do, just focus on this first 3 or 4 options. These all options we will be using as we progress. Let us get started. So we'll try to create a schematic here. This KiCAD supports hierarchical schematic. Here you can create a schematic under schematic. I mean the page under page. So modular design, it supports basically what it says it supports modular design. So let us say design a rectifier circuit. So it takes some time to load the all libraries, footprint libraries, symbol libraries. If you have very big library, it takes some half minute kind of time frame, and yeah, now it's loaded here. So here what we are going to do, we are going to design a rectifier, bridge rectifier, and we are going to put a regulator, filter, and then regulator. So basically we are designing from AC to DC converter. Just it will convert AC into fixed DC. If you know, there is a diode called 4007. So that's the diode. So this is the standard one. It's a 1000 volt 1 amps general purpose rectifier. Let us take this component from this library and place it here. Okay, you can click R in your keyboard. You can just arrange like this. So now we have drawn a rectifier, full bridge rectifier. we need to define input and output. So we'll define the input here, and this will be output, positive upside and negative downside. So we need a connector here, so we'll go and choose a connector. Yeah, screw terminal. So we need this type of connectors where we can insert the wire and we can screw it. So the symbol is looking good. Now what footprint we have to use? So let us use some 5 mm pitch footprint, terminal block 5 mm. So there are multiple items here. Again, let us not confuse with the multiple items. Okay, let us take the first one and we'll see later. So we have drawn a simple schematic where there is a 2 input and there are 2 outputs. Now since this is a root page, now we'll ask how to draw the next page. See, there is a concept. I already said this is a hierarchical schematic. So you have to draw page under page. So when I say page under page means you can draw a page here, a block diagram here. Let us call it as a add sheet. Use this option to add sheet. When you add a sheet, let me call this sheet as a rectifier. So when now you can see when I have added a block here, this block has added a schematic under the root. You can see the hierarchy. We'll move this rectifier inside this block. So just select Control X and just paste it here. So we got the rectifier section. So now what we need after this? We need a capacitor. Oh, who wants to join? Deny. Okay. Fine. So now we'll go to our page, rectifier page. So we are inside rectifier page now, and or you call it as rectifier block, all are same. So yeah, so now we need a capacitor. Just choose a capacitor from here. Just type CAP. So you can see here there is a single C, just C alone, which is unipolar capacitor symbol. If you want to use electrolytic, then you have to use polarized. These two symbols are there. I mean, there are multiple symbols. You can use any one, but the two very popular symbols are either capacitor is going to be unipolar or it's going to be like polarized, like electrolytic capacitor. So this is the symbol. Now what about the footprint? So footprint you have to decide. What is this? This is the outer dia and inner pitch. Dia and pitch. So what is the, let us say if you select anyone, sorry, these are the SMD. Let us go to through hole so that you can understand, have a better understanding. So pitch is written here, 15 mm pitch. Dia is 4.5 mm. It is axial. Axial means it will look like a register horizontal placement. So that we don't want. We don't want horizontal placement of the. We want to vertically mount the capacitor on the PCB. So you'll go to vertical, radial. That is called radial. Now it will be making sense to you. So pitch will be always lesser than dia. Let me go to okay, yeah. Let us select anyone so that we can understand it. So capacitor, through hole, radial, 8 mm, 5 mm. So we will choose this. Or maybe if you're not aware of what to choose, you can just go to Google and let us say if you want 25 volt 1000 microfarad, you take a 25 volt 1000 microfarad capacitor, just go to the website, download their data sheet wherever you want. You can just choose some standard capacitor. Let us say this. Let us go to Mauser or any wherever you find some data sheet of your component, whatever you are using. See, the capacitors are very. I mean, if you use a different make, it's very. I mean, obvious that the dimension will be different for the same value. So it depends on the quality of the capacitor. So now you can see this is called pitch. The two leads will be there. So center to center, lead center to center. Is everyone able to follow this?
Yeah. Yes.
Yeah. So this is called pitch, and this is called dia. So you just concentrate on this symbol, this diagram. Let's forget what, ignore everything. Let us not confuse yourself. Let us just, yeah. So this is called pitch, and this is called dia. So you have to be very careful about these two parameters. Vertically, how much it grows doesn't matter for now. When you come to the 3D modeling, there you will need to understand, I mean, how much height should be for my capacitor, and I should not mount a capacitor which is going to come out of my enclosure. If there is an enclosure and your capacitor height is beyond your enclosure, definitely you're not going to mount that capacitor. So based on that, you have to make a judgment. So there are multiple capacitors, like some capacitor will be, they will be all same value, same voltage rating, same capacitance rating, but their dimensions will change. I mean, if they will grow the diameter, their height will come down, or if they will grow the height, their dia will come down. So based on your requirement, you have to choose this. Let us not go in much depth. Let us just cut short from there. So pitch is, this is called lead spacing. Dia is the outer dia, I mean the outer physical dia of the capacitor. So now let us go to our this thing and understand from here. So this is called pitch. 1 to 2 is pitch, and this edge to edge, I mean the dia of this pink circle is your 8 mm, or this is 5 mm. Or if you want more, 10 mm, or how much that is. Just we are interested in knowing pitch and dia. Okay. So let us come there. Yeah, there are multiple bulk packaging details. Yeah, size is here. So there are different dielectrics. There are many. I mean, this is very wide, and if you want, you can. Very wide information is here. But if you want very precise information, I think they have put something here. Yeah. So P you have to find. P is 5. P is 5, and outer dia is D. You have to look. Sorry, H. They are calling it as. They are calling as D. Where is D? Okay. So pitch is 5. Dia they have. Still there is a problem in audio. Suresh sir, you please make arrangement to because yeah, you see this itself is a case diameter.
Yeah.
So 10. First one you will choose 10 mm and 5 mm. If you choose a bigger one, still you can mount smaller dia capacitance. But if you choose a smaller dia, you will be struggling in your because components will be very compact on your layout. Once you while assembling, you will face this problem. Let us have 10 mm dia and 5 mm outer pitch. This should be fine. What about this one? So this one is, you have 2 pitch. Let us say some capacitors with 10 mm dia, outer cell dia, might have different pitch. Like if you buy the capacitor, they will be like, some will be coming in 5 mm pitch, some will be 7.5 mm pitch. Still you can manage by having this kind of. Let us see. This is 5 mm pitch, and if you have a bigger capacitor, bigger pitch capacitor, you can mount in this 2. Or you can have a flexibility to mount in between also, between these 2. So this also you can choose. Let us take the standard one. 5 pitch, 10 mm dia, radial. Done. We have the capacitor now. Everyone is clear about this?
Yes, sir. Yeah.
Sir, allow others also speak, sir. I want to hear the voice from the people.
Just a minute, sir.
Maybe you can have a common mic.
Sir.
Yeah.
So actually, in the project la nanga paathuட்டு இருக்கோம். So any person's mic on பண்ணாக்கா actually இந்த noise create
No. I don't want anyone else to switch on the mic. If they will speak, still I can hear through your mic only, sir.
Yes, okay. Just
let the people speak. Any questions, sir? I'm able to hear 4 persons. Sir, see 4 persons.
Sir, actually, in Chennai. persons நாங்க ஒர்க் பண்ணி அட்டெண்ட் பண்ணிட்டு இருக்கோம். மேபி நாகர்கோயில்ல அங்க ஒரு 10%. So again, service engineers actually 5%. So totally I think the 21%. 20.
Very good, very good. Yeah, I would be more interested if people are having the computer and they are working and they are driving the cycle and they ask the question, sir, I'm falling, please teach me how to hold the cycle, how to make the balance. Then it will be more interesting, sir. This way it is looking for me like kind of a one way. Okay, fine, no problem. We'll cover whatever possible. For now it is okay. So if everyone is clear, I will go ahead with this. So you can just put here C polarize, or you can put your just a symbol, or if you just double click on the component, you have this many things. So description you can always modify, value you have to put here. So whatever you put here, see value, that goes and displays here, or you can just edit here itself. Let us say 25,000 microfarad, 25 volt. So now this is going to be my value of the capacitor. Done. So now this is my rectifier section. What if you want more than this, we can grow it. If you want LC filter to add here, you can add to filter out the noise and many other things. But this is very simple circuit. You want to just cover it. Yeah. So now the question is, okay, where is the input and where is the output? Okay. So the thing is, if you're drawing a whole schematic here, you can draw here. But since I am giving a training and teaching how to create modular schematic, this is the idea. Hierarchical schematic idea is idea of like a modular schematic. Let us say this is my one module. Let us call it as a module. The one module we have, which is a rectifier module, and we want 2 input and 2 output. So let us go inside. So how we can give the terminals to this module is, let us go inside this a page inside this module, and on this page you have to draw this thing, hierarchical labels you have to give. So hierarchical labels means it's kind of an off page connector in arcade. And yeah, off page connector means you can access from page P to page Q, or page X to page Y. From any page you can connect. That's why it is called off page connector. So it's not exactly the similar, but it's kind of same thing, but it is localized. The only difference is this is localized. So let's say we will how we will make use of it. We'll just I will show the demonstration. Let us select this one and give a label name. So what input we are going to feed to this circuit is 2 input, AC1. Let us call it AC1. So now there is another thing. There are many things. I'm just cut short those all options. I will just show whatever needed, so that you can have at least first cut understanding of how it is being used. Later we can explore more. If you have any questions, I will cover. So I'll just hit left button of my mouse and it is placed. Now there is a time to wiring this. I will wire this one to the first input, AC1. I'm calling this as a AC1. I will just select it, copy, paste. I will connect it to second input. Now coming to the output side, we have input. We have defined the input. No one is questioning why this is again AC1. It should be AC2. Otherwise, those both will be short circuited. Up to this, it is clear.
Yes, sir.
Please ask, sir, DC positive or DC P? DC output P. I'm just giving you some name, random name. You can give anything. So just wire it up. If anyone is not able to follow, please raise the voice, guys, so that I will hold for you, and I will explain if you have any question. So now what you got here is very simple rectifier. This AC input and DC output. This is going to be positive. This is going to be negative. If you want to do some decoration, that also you can do. Just hold the control key in your keyboard and keep selecting, and then right click and go to properties, or here itself there is option. Here also by this way also you can do. Just click here, say red. That's all. It become red. You want to make this thick so that the layout engineer should understand that I have to route this one thicker. No, this is all understanding and technicality inside the schematic. You can put more information. So there is no limit how much information you can put in a schematic. Let us put 5 mm. It will become very thick. Just put 2 mm. That makes sense. Or 1 mm. Yeah, so that is positive. And this is negative. No, I'm just showing the options, whatever possible. Any questions so far, sir? You can drag and select this way also. Just drag so that most nets should come and just select this way. But this way you have to go to properties and then you have to assign here. Junction size you can give or just leave it. Sorry. 0.254. Okay, done. Yeah, you can do whatever decoration you want here, whatever information you want here. But you have to just follow the standards. I mean, how to do the schematic. So
can we
go ahead?
Hello.
Yeah, go ahead.
So can we give the name for this line?
Yeah, you can put the net name also.
Yes.
By default, net name will be right now DC_P for this one. Or if you want to give the specific net name, you can follow this one, alias. Here, you can put add label. Make it positive. Or DC 9 volt or 12 volt DC. Is it fine, sir?
Okay, sir.
Just select that, put it here. This line has this net has the name 12 volt DC. Yeah, you're right. I mean, you can put whatever net name you want. Yeah. Or by default, it will take from your off-base connectors mostly. Or worst case, it will assign some net name, but you will be able to track that later point. I will explain those. But yeah, this is the way to give a net name alias to the net. Or maybe you can, yeah, you're right. So maybe you can use this one to give a net name to this guy also, ground. Is it fine? Or any other more question you have?
Okay, sir. Actually, you have used the subsidiary block, this one, no? So if I copy that another subsidiary block, means the net name will be changed or it will be same?
No, this will be local. That's what I'm saying. This everything is local. Whatever you see from in my highlighted pink is all local. Local means if you duplicate your, I will come to that. I will explain that. But for now, just understand this much is that this is going to be local. This is not going to be connected anywhere.
Okay.
This is specific to within this schematic. Whatever you draw in this schematic, this is going to connect to that. So yeah, I will come to that point. So your question was like whether this will be connected to other page also. Is that the question? I should understand.
Yes, sir. If I am using another subsidiary, means the net name will be same or a different.
Yes, it will be same. If you just copy this, let us say if you have used the 10 instance of this same block, and if you make any changes in one block, it will be replicated to all the blocks. I will come to that point. I will show that one. So let us say if this the only difference you will see is your ref days will change. Right now it is D1, D2, D3, D4 and C1. If you copy and paste this block and create another instance and 10, let us say 10 instance, so it will be starting from D1, D2, D3, D4 for first one. For second one, it will become D5, D6, D7, D8. It will follow the incremental order of your reference designator. Now let us come to the example. What you are asking? Yeah, everyone is clear up to this?
Yes, okay,
Hello.
sir. Carry on. Yeah.
Yeah. If you're not clear, please ask the question, sir, or I will hold for other people also to complete.
ஃபோர் டயோடு வச்சிருக்கோம். டயோடுக்கு ஃபுட்பிரிண்ட் போட்டுச்சு. இந்த 4 டயோடுக்கு தனித்தனியாக போடணுமா இல்லை ஒட்டுக்கா போடலாம்?
சேம் ஃபுட்பிரிண்ட்.
இல்லை நம்ம எடுத்து போட்டுட்டு
அப்படி போய் ஓகே.
Shall we go ahead now?
Yes, okay, sir. Go ahead. Sir, we will go for just
Sir.
சார் இப்போ எப்படின்னா நம்ம 4 டயோடு எடுத்து வச்சாச்சு. இப்போ வந்து என்னன்னா ஃபுட்பிரிண்ட் வந்து பார்த்தீங்கன்னா நம்ம ஏற்கனவே செட் பண்ணியாச்சு 4க்கும்.
Sorry, sir. my sensor, Tamil sensor is very weak.
Sir, okay, sir. I will tell you in English.
Are you? Yeah, English. If you try to speak.
Yeah, okay, sir. I already put 4 diodes.
Okay, very good.
I already assigned footprints also.
Very good.
Now I want to update that one, changing the dimension like that. For each one, I need to go and change the footprint, or for all time I will change, sir.
Very good. Very good. So very good question. If I understand your question, what you are asking is, if I have assigned 4 diodes, and let us say in between I have updated the footprint for this diode. So do I need to update the footprint for all this diode also? The answer is yes. You have to do that.
For individually, I need to
individually you have to do that. Let us say if we go to this diode, and I have used this footprint.
Yeah.
So let us say if you are creating another, if you are changing this footprint and giving a different name, let us say _1 or _2 or something, you are giving _5 or _new you have given. Okay. So what you have to do, you have to copy the whole string, copy. And I will just not change it. I will just make it, by default it will go to the old one. Yeah. So let us say if it is having new and we want to make changes of this, just go here, hit here, place it Control V, or just click here, go to the schematic, the library, and search your newly created footprint. It should be in the list, and you have to assign that, reassign that. You have to do reassignment. Yes, you are right. You have to do reassignment. Then only they will take impact, because that footprint is specific to this component only. Got the answer? Or yes, more explanation you need?
Sir, okay, sir.
Fine. Is there any question, sir, from other people? Please ask, guys. Please ask. Don't think I'm. Yeah. Nothing is going to happen. Just open your mouth. Ask the question. Some even silly question you ask. Don't hesitate. Any question, sir? Here.
Okay, sir. Next step.
Super. So now, this is the one rectifier block schematic, which is having 2 input, 2 output. Names are AC1, AC2, input AC. Output is DC positive, DC negative. Or you can give this name also. The same, whatever you want, you can use. Now we'll go to a root page, or there is option here. You can use this navigate up. Navigate up means it will come top of the hierarchy. Once you hit this button, this tool will take you on the top page by default. Just top of that hierarchy. So now we come up on the top. Now we'll do one thing. We'll make some decoration. You can go here. You can put the background color something. Let's say put yellow for now. So this is your rectifier block. Now there is no pin. So to expose the pin, you have to right click on the block, mouse right click, and there is import sheet pins. You have to go to this option. You have to place here. Now you can see, you can place anywhere you want. So AC is the input, so I'm putting left side. AC1, AC2. Now DCN has come. So DCN I will put right side here, and DC positive. Done. Now no hierarchical levels available. So now done. So all are now placed. You can resize it however you want. So now this block is ready to be used. Now this block is ready. So this block is having the schematic, just simple 2 input, 2 output, 4 diodes, 1 capacitor. Now just go to root or use that button to go up. So now this block is ready. Is there any question? Yeah, go ahead.
Sir, one doubt, sir. Sir, please one more time. The same. How to create the taking output for the AC terminal and the DC terminal.
Okay, right. So I will delete it for now. Those terminals I will delete it.
Yeah.
Yeah, I think very good. Yeah, I think you guys just follow this. I'm happy to hear. I'll be happy to do it multiple times. So now go to import seed pins. Right click on the block. Go to import seed pins.
Import seed pins. Okay.
Yeah.
Yes, sir. Yeah.
Now once you click it, you have to be very careful. Do not click randomly. Once you hit the left button on your mouse, you are in different mode. Now it is a placement mode. You have to place those labels. So AC1 I will place here. Left click, done. Once I move away, another pin will automatically expose. So AC2. Now come to the left side. DC is there. So DC negative I will put it bottom side. DC positive I will put top side. That's all. Once you see the message, that's all. Everything is done. I have redone this pin assignment. Done?
Yes, sir. Done, sir. Yeah.
Everyone is on the same page? Okay, fine. Now we have the one block. Let us say if we have this connector, let us connect this input. So if you want to have, or you can just delete it, move it a bit closer, or whatever way you want to connect it, you can connect it. It's all up to you. So I have just connected the input terminal to this block. So we have the AC input coming from here, from this connector. Now the DC output will be from this connector. And let us say if you want to use, let us complete first one chain. We'll come to the point multiple uses, or we can do that also. Let us cover this first, because this was the ask from the team, how we can duplicate it and whether the net name will remain same or it will change. So that to answer that question, I will just copy this, left click on this block, hit Control C in your keyboard if you are quick, if you want these things to go very faster, or you can always do right click and copy, and then you have to again do right click and paste. That will come up here. You just paste it here. Now you can see it is automatically incrementing the name. Rectifier 1, again do paste. It will do rectifier 3. So far we have, without any effort, we have done 3 schematics now. Now hit escape, and then the idea is you should be having a practice to drawing the schematic very neatly, very clear. So you should follow some thumb rules, some guidelines. The way I'm drawing, just learn that should be enough. Sometimes you might feel the issue that your this is not aligned with your the grid. So for that you can I think once that issue comes, I will explain. Let us not divert the topic from this. So just connect all the input to the same rectifier. All AC to the. Clear for everyone?
Yes, sir.
Now I will answer that question. So go to the rectifier, first rectifier. You see D1, D2, D3, D4, and C1. And this is 12 volt DC. This is ground. Now go top again. Go to second one. You see D5, D6, D7, D8, and C2. Is it following the ref increment order?
Yes, sir. Yeah.
Yeah, it is following that. But you see net name, they will remain same. They are looking same, but when you do placement, you will feel that they will be in hierarchical order. Like they will have the same net name, but actual net name will be rectifier 1/12 volt DC, rectifier 2/12 volt DC. So that way this tool handles that distinguish between the same hierarchical duplicate. Everyone is clear till this, or?
Yes, sir. Clear, sir. Clear. Okay.
Sure. So now we'll go to the next stage.
Yeah.
Or shall we finish this itself? Or I'm not sure. If you want, if you can finish here also, or I can draw the regulator section.
Yes, sir. We have followed, so no issues.
Sure. So now we'll go to the another. We'll draw another block. Add sheet. We'll call that as a regulator. There are many technical things. I'm not going into the depth, but yeah. But this is what, if you learn this, that's all. You will be able to do everything. Okay. I will go to this guy's properties. We will disable this, or you can have it. Doesn't matter. It will be too much clumsy if you have that. I will make this some different color or some yellow color. So this is regulator. Yellow is my rectifier. Little yeah, dark yellow or orange is my regulator. So here, what regulator we should use now? Do you remember any regulator name?
7805.
Sure. So we'll go to that. You'll just type 7805. One more thing. Let us. Yeah, TO220 is already there. I think, yeah, this is okay. So it's a 1 amps 35 volt linear regulator. That's 35 volt is a max input. So it's all details are here. Footprint is here. You can choose different one. I mean, if you want to mount it this way horizontally or vertically, or like yeah, this is F version. F means the plastic version, which is not going to have the tab exposed. But let us use the default one, vertical. This is what, I mean, mostly we use. Let us select this. So we have input, we have output, and we have ground. That's all. Only 3 terminals we have. So we need 2 inputs and 2 outputs for this as well. So we'll mark. We'll give the nomenclature some useful way. DC in or DC in positive, guys. Please draw along with me. If you have any question or if you are lagging, please let me know. I will slow down these things. Okay. Now next thing is a ground, or call it as a DC negative, because DC negative is going to be common both the sides. So okay, yeah, done. Maybe you can draw this way if you want. Oh, okay, not necessary. Let us not make it complicated, unnecessary. So DC in negative, just call it as GND better. So that is also another learning, that you should not use unnecessary, very complicated names. It should be very universal, very generic, very simple to understand. It should not be confusing. Yeah, it all comes with experience. Once you learn the tool, you start drawing it, you will come to know that, okay, yeah, what is the best practice. So DC out positive. Now you need C in and C out. So what should be the value of C in and C out? And what capacitor we should choose? I'm not covering the hardware design part, but I would just want to give you the brief capacitor value. What capacitor we should choose for this?
2200 in general. Already we had designed one.
Sure. Yeah. If you know, let me know. Okay. Yeah. Tell me. I'll just follow that. So scene will be, just go to again symbol and just type, or if you want it to be more quicker, just go and copy from some from the older one. Or okay, let us not confuse there. Let us choose from the library. So we'll choose the polarized one, and we will use some footprint, radial footprint, and maybe we'll go with what is the pitch and dia, sir? Do you remember?
Pitch means I think 5.
12.5.
12.5 is a dia. Pitch is a 5 mm.
So 12.5 is dia and pitch is 5 mm.
Yeah.
We'll use this one. Done. That is C in, correct?
Yeah.
Okay. So that is, what's the value for this?
2200.
25 volt, 35 volt.
Yeah, 25 volt actually.
Sure. So this also is very important. I mean, these values, if you put unexpected value, your output won't be stable. It might oscillate. So C in C out has some spec. I think that might we can cover in some hardware design part later. But for now, just for get going, let us go ahead with this. So we got 2225 volt C input and output capacitor.
Put 10 microfarad.
Okay. So for 10 microfarad, we need different footprint, correct?
Yeah.
So we'll go here, we'll edit the footprint. And now tell me what footprint we should use here. Because if it's 10 microfarad, it's going to be 10 microfarad, 63 volt. I think that's the more standard we have available, but I think lower voltage also are available. So we might go with 2.5 pitch or yeah, go ahead.
Sir, 5 2.5. 5 is a diameter.
Perfect. 5 and 2.5. We'll go with this gap. Yeah, here if you go this mode, you will be able to see this 3D view also. So this, if you hit this, you should be able to see the 3D view of this capacitor. It is going to look like this. Is it clear to everyone?
Yes, sir.
Yeah. So 3D view also you can see live. Okay, we'll come to this 3D part later. Just for understanding, I have shown that one. Okay, so 5, 2.5 we have chosen for C out. And the value is going to be 10 microfarad. And voltage is?
63 volt.
63 volt. That's going to the standard one. Okay. You can put your description also, sir. It's a electrolytic capacitor, what kind of capacitor, or any specific make name you want to cover. I think there are multiple things to cover here, but I'm just skipping for now. We'll maybe discuss it in detailed video if you have the question. If that need is there, then we'll discuss that, or we'll skip that. Okay. So now you have assigned C in, C out, and the regulator. So the regulator is complete now. Similarly, if you want to see this also, you can just hit double click on this, go to this guy, hit on the footprint. Okay, it went. Okay, now go to 3D. You can see this is how it is going to be mounted. Okay, done. So now our regulator section is complete. Regulator C in, C out. That's all. If you want to put any protection or something, you can do all those things stuff here. If you want to give any net name, that also you can give. Let us give some net name, useful net name. DC or 5 volt DC. You give a net name to this guy. So now regulator section is done. Now we'll go to the top of the hierarchy. So we have one regulator. We want to duplicate it. We'll just put it, this guy, another one, this guy, another one. So this way it is complete now. Yeah, it's not yet complete. Let us complete one guy first, then copy. So to complete this one, we need the pin, import the pins, seat pins. So just import the seat pins. It's saying DC out positive. We put it here. It's saying DC in positive. We'll keep it here. Ground, we'll keep it. That's done. Or if you want to put, you can keep ground down also. We'll do that later. Done. So now we'll just wire it up. Everyone is done until this stage, or?
Yes, sir. Yeah.
Yeah, please let me know, guys, if you are lagging behind. I will wait for you. So this way you have to make the alignment. If it is not, or maybe this alignment itself is. So now we have 3 DC outputs. There is a 3 rectifier section, there is a 3 regulator, and there are 3 DC outputs. Now if you'll ask me, are these 3 grounds are same? What is the answer?
Once more, sir.
Whether these 3 grounds are same? Can anyone answer this question?
Yes, sir. Common ground, no?
How,
it is same.
How it is same, sir?
Actually, you can declaring for the global variable, na, sir. The ground.
No, I'm sorry, sir. I'm asking from some other team members.
Okay.
If anyone can answer except you, because you might be answering, but yeah, I just want to answer.
I think it is not same, sir, because it is in local is in hierarchical it will be a local. If it is in the ground.
Hello, yeah. No, you're right. But yeah, no, you're right. You're absolutely right. This ground is localized to this block, this regulator block, and this ground is localized to this regulator block. As Suresh sir told, it will be common. His answer is also correct. Ultimately, they are all tied to the same transformer, so all ground will be same. I mean, they will not be like, if you see continuity, they won't be same. In between the 3 series diode will come. Diode 1, diode 2, diode 3. Which diode will come? See, these 2 diode will come. D2 and D4. So this ground is localized to this schematic. Whereas, if you come to this ground, that will be localized to this schematic, which comes from D6 and D8. You understand? Clear that point? Everyone is clear?
Yes, sir.
Yeah. So you cannot sort this 3 ground. Now we need 3 outputs. So just copy the same connector, place it here, or just right click. There is a transform selection. You can transform it to vertically, no, horizontally. Horizontally, just mirror it. So the pins will be left side and connector will be right side. So this way you can do it. Okay, it's not aligning. There are, see, once you're expert, you know how to. I mean, yeah, there is a key, but I will tell that thing later. So what you can do, either you can connect this directly here, because that's the ground you have. But if to make this clean, if you want to make the schematic clean, you might duplicate this pin the right side also. But let us say make it let us not make it confusing. Just copy it and paste it. That's all. If you know how to do it, I mean, once your hands are now very much practiced on this tool, you'll be draw in a minute. Actually, it will not take much time for you to draw. Everyone has reached to this stage. Now we have finalized the schematic.
Just a minute, sir.
Yeah. Maybe we'll take 5-minute break if you guys want.
Yes, sir. No time long.
No, if you want. If
so 11:30, sir, actually. No problem.
Sure. So 8 minutes more we will continue, and then we will have a break for some 5 minutes. So now I want to hear if everyone is done with this. Can you show your videos so that I can see the people? So I'm seeing 4 people only drawing the schematic. Am I right, sir?
Sir, here totally available for 8 people. The camera is only focusing for 4 people only. Remaining people are the other side.
Okay.
And also the somebody persons available in Nagarkoil region. So that place is also they will do for the practice also.
Very good, guys. So everyone raise your hand if you are done. Not done? No, I'm assuming you all are not done. Oh, someone has raised the question. What's the question? Guys, you speak on the phone camera. There is no harm in asking the question. Suresh sir.
Yes, sir. Yeah.
No one is responding, sir.
Sir, actually, what the problem means, people should be going to switch on the mic now. She said disturbance. So that's why we are not an
No, I can hear if they will speak from there. Through your mic, I can hear very clearly.
Okay, no issue.
Go ahead, guys. Raise your hand if you are done. Then I will assume it is done.
Just 1 minute, sir. People are going to finish the stage now.
Yeah, I will wait. That's what I'm saying, because after this it will be a different window and different thing. New thing will come. So here I will not be coming back again. Maybe we'll be doing to and fro, but yeah, let us complete one stage and then we can easily go to another stage.
Schematic window. So can you show me your schematic window?
Great. Here it is.
Yes. अभी नहीं तो क्वेश्चन देख रहा हूँ. और विघ्नेश कर अच्छा. So yes, sir, you carry on, sir.
Sure, Suresh sir. So now we will go ahead to another stage. Now as our schematic is complete.
Yes.
So the very basic thing is to one more thing I think I should cover. Let us say if you want to make some correction after making the schematic, and you want to make some correction to this guy, and you want to move this diode here, I will just perform some move so that I will not alter the schematic. Let us say if you want to move here or do some correction. Let us say I made one correction. Just I moved the D3 some here to just right side. And now you will ask another question, whether I need to make that correction to all these blocks also? No. Once you did to this block, and you can see that the diode is D3, D1, D2 and D4 are not changed. C2 is also not changed. Now when you come to another one, you can see D5, D6, D8 are not changed, but only D7 is moved. So this says that whatever correction you make to one block, that will be reflected to all the copied blocks. Now we'll put to the same location, and now you can see this all diodes are on the same location in all the blocks. Everyone clear here?
Yes, yeah.
Similarly, if you make any correction here, you need not to go and make the correction to 100 places wherever you have used this regulator new schematic. So that much time saving it is. You need not to work 100 times, go and edit each block. No, not needed.
We want that block only changes, not affecting my other block. What can I do?
You can't do that. You have to draw different schematic.
Okay.
You have to draw different blocks. 2 blocks you have to draw for that. Let us say I will draw another one. First one I will call rectifier, and then I will draw another one I will call rectifier 1.
Okay.
So what will happen? The key is here. Let us see. Key is here. If you go to properties, I will show you. So what I'm saying, see, this is the seat name. Seat is rectifier.kicad.sch. We are not showing that, but if you show that, maybe it will be clear. You can draw 2 different, and your job will be done. But now you see here, your name is different, block name is different, but the schematic remains same. Can you see that? File remains same.
Okay.
So if you make any change to this schematic, basically this is the same schematic being used here, no?
Yes.
So that's why this here also the same changes will be reflected. if you want to have two different, you have to have two different schematic. So once you have two different schematic block, you can do XYZ changes here and PQR changes here. They will be independent. Right now it is not, because this hierarchical and modular, I mean repeating blocks will use the same schematic. That's why you cannot have different. I mean, if it's the same schematic, there will be only one change. If you do one change, that's all. Everywhere it got reflected. Clear? Everyone is clear till this stage? Now we will do one thing. After this, just go to root. Just left click on root. Go to inspect. You can do whatever check you want. You can do annotate schematic. You can do. If you have given some random ref des, you can do run annotation also. Once you go to an annotation, you can choose you want to do only current sheet or entire schematic. I want to do for entire schematic. You want to do left to right or top to bottom. That's also up to you. You can keep existing annotation, or you can reset. So we'll go with resetting existing annotation. What this will do actually, once you hit annotate, it must say annotate complete. It should not give any error. If this message you see, that means your job is done. Just close this. So what it will do, I will tell. You might have copied several times some components. You might have given D1, D2, D5, D20, D17. Randomly, you might have given some reference designator. This will clean up everything and make it in serial wise. Serial wise, when I say, that means is from top to bottom. It will do annotation from by X position. So first column it will complete, then second column, then third column, then fourth column. That way it will do reset and it will reassign the reference designator to all the components. So this is the thing at minimum you have to do. At least just save it. Now the next step is to create the netlist. So I think that step we'll cover in next, or maybe I will just cover that, then after we can take a break. Just be on the root, go to tool, update PCB from schematic. Before doing this, I will go to that PCB and I will show you what is there. See, the third folder will be automatically created. You need not to be worried about this, why this folder has come up, because when we created project 1, we were having only these two files, one called PCB, another called schematic. At the end, you can see .KiCAD _ PCB .KiCAD _ SCH. This is schematic, this is PCB. Why this has come? This is the feature of this tool. It will create a continuous backup of your whatever you are doing, so that so far it has created 6 backups. I think each 10 minutes it is creating, or each 15 minutes it is creating. You can see the timings here. So this is your backup folder. So not worry about why this folder has come. This is automatic backup of whatever you are doing. What if you have missed something, you have lost something, your PC has got shut down suddenly? What will happen? This will be there in the backup. It will try to load, auto load. So you need not to go to this folder and do anything. No. This is only for the KiCAD tool. Tool will fetch the schematic from previous versions and next version, or wherever it finds convenient. It will show to you on your once your laptop restarts. Now coming to the schematic as PCB part, just open the PCB and you will see a dummy, just a blank page. Just I hit the double click. You also guys just try and hit the double click. Everyone is done? I'm not able to hear any voice, guys.
Yes, sir.
Please encourage your guys to raise the voice, sir, and ask the questions. Be friendly. No. Be friendly. It's not I'm strict and see, you be flexible, guys, and ask any question, whatever you want.
Yes, sir.
And answer to my question. Instead of Suresh, sir, you guys say yes or just ask any question or answer.
Just sir, during the tea time, I will encourage all the person.
Sure.
After tea time, after tea break, they will be.
Just 2 minutes more. We'll go to tea break. It's 11:33, 11:35. We'll go to tea break. So now this is the window you should see. There is no component, no placement, nothing is there. I will come to this GUI. I will explain all the options, whatever is available here, or at least okay. So before that, I wanted to make you guys aware that there is no component placed here. Is there any component placed here? No. Just close this. Or if you want to let it open, you can let it open also. So now we were inside the schematic page and how to create netlist and go to that layout page. So for that, you have to just hit on root tool, update PCB from a schematic. This feature you can use, or you can just hit F8 in your keyboard. So we'll update PCB from schematic. Once you hit this, you should see this window. Update PCB from a schematic window. Here there are three options: relink, delete options, replace footprint. All must be checked in. And you should see total warning 0, error 0. If this is the state of your schematic and this window, if you see, it means that your schematic is correct. Whatever assignment, footprint assignment you have done is all correct. And now you're going to update the PCB. Hit update PCB, close it, and now you should be very careful after hitting the close button. All your components are come here, and now you're holding in your mouse. It's in active position. Sorry, active state. So now you have to click this somewhere. Okay, let us just keep it in center or on the left top or left bar, wherever you want. The recommendation will be to put on left top. Just hit left, hit escape button in your keyboard, or right click, or you can escape from here also, but just hit escape button in your keyboard. That's all. And now you should be able in the select mode. So now you have placed all the components. I mean, all the components has come to your layout editor, PCB editor. Now after the break, we will start from here. Our schematic is done. We have moved all the components to the layout PCB editor. We have imported all the components. Now I will give introduction and I will tell how to route all this. I mean, how to do placement and how to do basic routing. Yeah, I will just cover those things after the break. So you can go ahead, sir.
Yes, sir. Yeah, thank you, sir. So after 10 minutes, 15 minutes, I will come back.
After 10 minutes, please, encourage the guys to ask more questions. So guys, this session will be open. Whoever wants to just keep the things on mute and you can leave. And once you are back, this session will be open. And after 5 minutes, like 11, 40, 40, 42 will meet. 40 or 40, 41, 42 will meet. Suresh, sir.
Yes, sir. Yeah.
Sir, yeah.
Yeah, thank you, sir.
Hello.
Yes, sir. Now ready, sir.
You are ready?
Yeah. Yes.
Okay. Very good. So now we will go ahead. We'll start. We stopped. Okay. So now let us resume to the conversation. Yeah. Some people are arranging the chair. Okay. So yeah, everyone is ready. Guys, everyone is ready?
Yes, sir.
Yeah. So now what we will do, we'll go ahead with this PCB editor GUI. So same like Orchid. Technically, there is no much difference. There are differences, but there are feature-wise, it is more advanced than Orchid. I mean, there is another version, Allegro. Of course, with respect to Allegro, I won't say it is like to that level it is, but yeah, it is comparable. So of course it has better feature than the Orchid what we are already using. So now let us go to the GUI intro. So you can access all those options from here also, but major options are already either on the top bar or in the sidebar. This bar I'm saying. Similar to the schematic, this bar is there, and this is the layout, object, and nets. All these three options you can access from here. So which layer you are working on, and I don't know if everyone is aware about this one, because this is going to be a little confusing for the people. Are you guys aware about the masking, silk screen, and paste, solder paste? I'm asking a question, sir. Is everyone aware about this, all these things?
Yes, sir. Yeah.
So I will ask a question. What is silk screen?
So that is a symbol and a polarity.
Is the top of the PCB, sir. This is the top of the PCB. This is come to for the white color border, I think.
yeah. That is for the, yeah. Silk screen is just for the user information purpose.
Yes.
There you can see. I mean, for the placement component during the production, to read the ref desk, like D1, D2, D3, where those D1, D2, D3 are there, their outline, their symbol will be there, so that you can place all those. So there will be one layer, one numerical, alphanumerical layer, and one drawing will be there for logical, symbolic drawing will be there for all the components. I mean, let me go to the real this thing. See. Yeah. So whatever you see in the yellow color, those that is the silk screen. So that is the information which gives a user where to mount the component. So they have to insert two leads inside this hole, and they have to keep right side as a negative of the capacitor and left side as a positive. So there is a plus symbol. So all this information is just a ink print, comes in an ink print, and that print layer is called the silk screen. So the color here, what you see is not just, I mean, not hard and fixed. You can change any color, but whatever is most optimum color, this tool has already assigned. So like white and cream color, what you see, not pure white, it's a kind of a yellowish and white both mixed. So cream color, I would say, is for the top silk screen. See, yeah, the nomenclature I had to, I will go through this one, but I just wanted to know whether you all guys are aware about this one. What is masking, sir?
Solder masking.
No, not. I'm not asking Suresh sir. Suresh sir, you please encourage your other guys to answer and communicate. If you can, yeah. Why video is showing on the terrace? Yeah, guys, please be friendly and ask more questions. If if I'm answering, please try to answer. What is mask? Okay. Let us do one thing. I will assume that you are aware about this. This layout tool, Orchid layout. Whoever has already worked on Orchid layout, they will know all these technicalities. Or else, people have to go through this. Let me walk through at least once, because I'm not hearing the like very strong answer. Okay, so F is front, B is back. So wherever you see dot means it will say the information. So F dot CU means front copper, B dot CU means back copper, F adhesive means front adhesive, B means back adhesive. There will be some glue, some double-sided tape or adhesive irukuna அந்த மாதிரி இத adhesive actually, but this is not exactly the same glue adhesive. It's some different type of, I mean, this is not used for our application, this is used for some other application, where you want to stick the board on some component on the board or some label on the board or something else on the board, and the adhesive area use panikalam. Paste is your wherever you want to expose your solder, that is called the paste. Actually, while reballing or you might have used for SMD soldering, you will be using the solder paste. So the area where you want to apply the solder paste, that area is called the paste. So front end F dot paste is for the front of the PCB, and B dot paste is for the back of the PCB. Silk skin, just now I explained, it's the reference designator and the symbol are going to be displaying under the silk screen. And this all information is already there on the internet. You can just Google it and you can find out numerous examples what those things are. Bottom means, if I will disable, there is no bottom side silk screen we have not put so far. But if you want to mount some component from the bottom of the PCB, let us say if you want some jumper or some specific component you want to mount the bottom of the PCB, so there should be written what component you want to mount. Let us say if you want to mount this D5 diode 5 you want to mount on bottom. So I'll move this one to the bottom side, flip side, change flips. If you use, it will go in bottom. So now you can see the color has been changed. Now it is not looking yellow, it is yellowish cream color. It is looking some backside silk screen. Now if you disable it, now you can see this will be displaying in the bottom. Okay, so I will just cover all this, then I will come to that thing later. I will just give you an introduction what these things are. Masking is, again, it will mask the area wherever you want to, you want to expose the copper. So masking means your film is not going to cover this area. That's the meaning of masking. You can apply masking on top and bottom, both the sides. User drawing, if you want to draw some drawing just for information purpose and still you want your Gerber file to be unaffected, you can use this user drawing. Similar user comments. Eco 1, Eco 2, I think this thing you can ignore. The main important thing is this guy, edge cut. Edge cut is the boundary of your board. Wherever you want to provide cutout in your board, whether it is boundary or internal or there you can use the edge cut. Margin is it will show the placement margin. Let us say if I enable the placement margin and disable this guy, okay, so that will, here you can see that. So this much margin is there. I mean that is a kind of a spacing which is must to have to avoid any short circuit. Okay, now if courtyard, so that will give you the placement. You must not overlap this courtyard. You can see if I'm overlapping, it is getting red color. So this courtyard will help in placement. Similarly, the back side courtyard. So whenever you are having two components placed in bottom side and both components are in very close proximity, you have to maintain some spacing between those two so that they should not be very, very close. Otherwise, when you do the real placement of those components will hit. Physically, they will be mechanically, they will be fitting on the placement. So for that purpose, the courtyard is given. Fab is for fab purpose. Doesn't matter if you want to go for auto fab, you can use this, or just you can ignore for this. So I think you can create n number of other definitions for you. That is open for user 1 to 9. So I don't think this thing is important to cover. So I think I have covered most of the things. Now here comes the tricky part, which is more important to where you should be focusing more. So there are 2 to 3 things where you should be focusing more. The focus more is top copper, bottom copper. Now I will ask one question. If you have one layer copper, one layer PCB, which copper should be enabled? Front copper or bottom copper?
Bottom.
Can anyone answer? Bottom. Everyone answer is bottom?
Yeah.
Can't it be top? Front copper?
No. We can place the copper from the top and the copper here will be at the bottom side.
Yes. Yeah, but you can do opposite also. Let us say if you have SMD components, not through all components, then which one you have to use? Front copper or bottom copper?
Front copper.
Yes. So for all the through hole components, you have to use bottom copper, or all the front was. No, it's all up to depends on how you are designing. Still, you can keep bottom, but you have to place all the components in mirrored. You won't be seeing the straight. You cannot read it. It will look like you have placed all the component bottom side. So okay, it's all up to the preference. But yeah, just for your information, these two are very important. And silk skin is very important. So front copper, bottom copper, front silk skin, bottom silk skin, and the paste wherever you want to apply soldering. Not paste, mask. Wherever you want to expose the area for soldering. So 1, 2, front copper, front silk skin, bottom silk skin, front mask, bottom mask. That's all. Here you have to. These are the 3 items you have to be very careful while doing placement, as while doing the actual layout. Okay, silk skin, copper, and mask. Apart from that, while placement, you should be very careful about the courtyard. That's all. Now this is the yeah. Go ahead. Any questions so far?
Okay, sir. Carry on.
Sure. So these are the things which we will be keep moving and using these things later. And net classification also is there. If you want to highlight different color, different net, you can do that. Maybe I will do one thing. Okay. So 12 volt DC, you can see here all are looking which color it is looking right now. Is it visible to you guys? Blue color, something bluish color.
Yes, yeah.
Now you can give a color to all these things also. Whenever you hit here, let us say, let me first give introduction to this, then only will come to this guy. So what this is to select the item. 90% of the time you will be always here only. Yeah, local rate nets. And this guy is the component. If you want to add any footprint, you can add from here. Manually, you can add out of the scope actually. If you want to put some holes, some different cutout, different logos, you can use this option. And this is the routing. You can use this to route the nets. This is to length matching if you want to do. And if you want to modify some vias, pad stack, everything, all that can be here. If you want to do copper pour, you can use this. If you want to put some rule for keep out for some area, you can use this option. These are all decorative drawings you can do. You can put even image also, reference image. You can put text. You can add text to your this thing. You can add a text box also. And you can do measurement. If you, let us say, if I want to measure what is the spacing between these 2 pads, you can use this tool. This will, yeah. Okay. Next thing is, if you want to interactive delete, you can use this one. You can enable and disable grid by using this one. Grid origin, you can reset the grid origin by using this one. This one is for you to do a measurement. This both are thing, but this is more precise. Let us use this one. So what it will do, it will auto align. If you go here, it will auto align to the grid. So how much it was, sir?
Yeah, 5, sir.
It's now you can see it is 5 mm. So this is the thing actually. Yeah, I've just given a rough intro, so that let us not concentrate on that much. Let us use and be familiar with this. So first thing is in this layout is to put a edge cutout. Edge cutout means my board boundary. So now you have to be very careful here. This step, what I'm saying you are seeing this arrow. Wherever this arrow is, that activity will happen if you do right now. If you want to do something, anything, in draw any symbol or any measurement, anything, that will happen in this courtyard layer. Now I want to work on the front copper. You have to click here so that this front copper will be selected. Back copper will be selected. Right now it is in back copper. but we want to put a board boundary. We'll go to edge cutout, and we'll draw. We will draw a edge cutout here. So to draw edge cutout, we'll take this thing, rectangle, and we'll go to edge cutout. We'll draw some rectangle, something. So what size? What's the size of our board? Dimension of our board? That parameter we have to enter here. So yeah, just you guys tell me. I mean, do you have any specific thing, or you can just draw a big one? Just suggest, Suresh sir. Just go ahead and suggest some dimension.
So you can flexible, sir, no issue. So maybe
be interactive. I'm not saying yeah I'm going to use whatever you're saying. Maybe yeah I'm just saying so. Say something.
Sir, actually 30 centimeters, sir. 30 millimeter.
No, but, yeah.
150 and 100, sir.
150.
In general, our usually we are usually for the VBMB box now on general purpose PCB.
Super. So we'll use 150 and 100.
Yeah.
Okay.
Yes, sir. Yeah.
These are the width and all you can have to, but yeah, but leave all the things are the default. Just go ahead with entering your dimension. Okay. So it went ulta. We'll put 150 here and 100 height here. So height should be 100 and width should be this much. Yeah. So now comes the part. This is our PCB. What I will do, I will select all this component and keep on the PCB. See, I didn't do anything. Any routing I have not done. I will just deselect all. And now I will just go to view. There is a call 3D view. Alt 3 also you can hit to go to this view. You'll be able to see your PCB. See your PCB is looking like this.
Yes.
If you enable the through hole components, all your through hole components are here. So far I didn't do any routing, anything. So this way you'll be able to have some estimate that, oh, my components are okay. I think I can do a placement within this much area. This much area is not required. I think you can have some estimate. You can have some understanding of how your components are placed, how they are looking. Yeah. So now we'll close this. We'll go to the actual placement. Now the magic comes here. You have total 3 rectifiers and 3 regulators. So just go to your schematic, go to the top page. What placement you want to make? You want to first define the input. Let us select first this thing. Once you selected the block here, your whole schematic, your symbols are selected here, all the components. Now make them apart. Rest others you can select, keep outside for time being, and put all this component inside. So this is your first rectifier, first regulator. Now what is J1? You can come here, you can select, this is my J1. I want to first place this thing. So this is my J1. J1 I will place here, let us say on the edge of this. So if you further zoom in, you can see the net names, rectifier / AC1. This is the first block. Rectifier is the first block, net name is AC1 and AC2. So then the 4 rectifiers will come here. Then the regulator will come here. If you know you can do this placement, are you guys doing this in parallel or just I am? Go ahead.
Sir, you can do, sir. After that we can do.
No, you also do in parallel. I will hold for you guys too, because if I will do, it will not be useful for you. Unless you drive the cycle, you are not going to learn. I am only going to learn. So I have just put left to right fashion. Connector, all the 4 diodes, then the bulk capacitor, then the input capacitor. I think both are not needed. You can have only one. But if they're very close proximity, if there is going to trace in between, longer trace, let us say this longer trace. I mean, the idea is if you're going to add inductance in between these 2 cap, you must have this cap. Or if this is going to be very close by this cap, if this is going to be very close by this cap, then this C1 is not needed. C4 itself will do serve the purpose. Yeah. So for now we'll ignore all technicality. We'll just concentrate on layout. Now this is output. Okay, see the symbol reflects. Okay, see here. Yeah. So now we have completed the placement for one section. Everyone is clear up to this?
Yeah.
Yeah. Let me know if you have done the placement like this.
Wait a minute.
Just a minute, sir. We will do that.
Yeah. No issue. No issue. I'll wait.
Schematic mask. Like in the footprint or schematic? Footprint. Sir, can you show the footprint, sir? Layout view. Yeah, yes.
Yeah, I think this should be enough. So readable.
Input first. Yeah. Input AC transformer. Okay. J0 one அது capacitor. அதுவும் capacitor. அவுட்புட்ல வந்து அது ஒரு capacitor. Next button இல்லமா அது பண்ணி அங்க செலக்ட் பண்ணா அதை மட்டும் செலக்ட் பண்ணா அது மட்டும் சூஸ் பண்ணணும்.
இங்க செலக்ட் ஆகும். மத்த எல்லாத்தையும் எங்க ட்ராக் பண்ணி இது எங்க ட்ராக் பண்ணலாம். புரியுது. ஃபர்ஸ்ட் செக்ஷன்ல
அது ஹோல் செலக்ட் பண்ணிட்டா இங்க வந்து
So yes, sir. Everyone is done.
Yes, sir. Yes, sir. Carry on, sir.
Sure. So now we'll go to the next stage and we'll try to complete the placement same as the schematic, but it's not necessary. The only thing is you should follow some convention that left to right flow is the power flow, top is key. It's not mandatory, but you should think in all the aspect. Mechanical aspect. If you let's say in future, if you want to mount the heatsink to this regulator, you should not keep the regulator just behind the one capacitor. It should have enough clearance, or you can use a regulator with heatsink footprint. Yeah, from all the angle you have to think, like how much current is going to flow in this pin. These all technical things, electrical understanding, one layout engineer must have. I'm not saying he should be expert, but he should be having at least basic understanding of how much current will enter, so that he can decide how much thick trace we have to place. Just 5 milliamps of current, he might give a very big plane, and for 2 amps of current, he might give very thin trace, which is not acceptable. We should decide the thickness of your routing accordingly. So you should have some understanding of electronics, basic electronics. Yeah. Now we'll go ahead. We'll place the components in a fashion. So here we should keep in mind that we are designing a single layer board. Single layer board means ideally we should target to not have any jumper. At the same time, we should not compromise on our electrical performance. We should not give some jumper or some very thin trace compromise to your jumper. It's all like trade-off. If your jumper will solve the problem, let us have a jumper. But if you are trying to not have a jumper, and I will come to that point, but let us say if you are not going to have a jumper and still you are trying to manage the routing, crisscross routing, and this is going to mess up your schematic, which is not good. Yeah, the layout should be very strong and clean. Okay, now I would recommend one more thing. Okay, it's all up to your preference, but you may disable this, or you may disable the silk screen, so it will look much cleaner for you. But it all up to you. Now you see, you go to the schematic, and your D1, D2, D3, D4. Okay, so D1, D2, okay, D3, D4, fine.
Yes, sir. Yeah.
We are going to have top positive and bottom ground. So we'll rotate the capacitor to match that. See, this is not actual. I mean, I'm not recommending to make 100% the way I am making. It's all up to you actually. It's all up to the individual how they are planning to do. We might have some space conjunction. I have this much land. You see, this 5-acre land is there. So we are drawing very luxury, but there is no 5-acre land. You have to manage within a given area. You have to be very intelligent in the placement. Placement is the main key. I would say 60 to 70% of the layout job, the intelligence comes from the placement. If you do a wrong placement, you'll be spending your 80%, 70 to 80% of time just managing the routing. That's all. If placement is wrong. If placement is perfect, then your routing is very, very simple. So I'm not going to much technicality. I'm just focusing on the placement. See, guys, I'm just making it like 1:1. Are you able to see this?
Yes, yeah.
Routing. It comes here, it goes to here. This guy comes here, it goes to this guy. This will be all covered into a single layer. There is no cross routing happening. You have to be very careful if there is a cross routing. You should do a placement so that there should not be any zero cross routing. You should achieve, the target should be to achieve zero cross routing. See, there is a regulator. Yeah. So now you see there is a problem. If you do a placement here, maybe I can switch to this guy, to 3D view, so that I can explain to you. Now if you put a heatsink here, this much area is needed. Am I right?
Yes, yeah.
So I have to make it free. If I put a capacitor just close by, in future there is no scope that I can put a heatsink here. But the idea is you must put the capacitor as close as the. See, there are many technical things I'm not covering here. Just I'm teaching the layout. That's why I'm not going to that technicality. But if you come to the actual technical point, where should this capacitor should be placed? There is a recommendation. You should not place these capacitors much away from this regulator. Should be as close as possible to this regulator. Okay, forget about those things. Let us complete first the placement. Yeah, maybe what we can do, we can move this guy this way. Let's do that. Okay, yes, our power will be on the top side. I will be able to still put this thing here. And connector is, right connector is this side. So the idea here is top side is positive, bottom side is ground. This all bottom is ground, this all top is positive. Same way you have to do the placement for others. So I will tell you one more magic. So far I have not touched any component here, or I have not touched any component now.
Yes, yeah.
Yeah, I have not touched. I am just placed only one block. Which block? I placed only this block. This section only I have done the placement. I will do one thing. I will do routing of this all. I will complete the routing of this. So we'll do the routing. For doing the routing, what you can do, you can disable this silk screen, and maybe, yeah, so that you will have a, or this also, courtyard. So we have very clean view. Now you can do a routing. So for routing, we'll go and select the route track. See, before this I missed to say one thing. The thing is, you might have some cutouts in your board or some holes in your board. You want to put some placement hole, mounting holes. So those things you should do at the beginning. First thing should be drawing a board boundary. Second thing should be drawing a hole. You may include hole as your net list, or you can place hole externally also. Here also you can just mounting holes. 2 mm holes. I think 3.2 mm holes is good enough for us. We'll go to 3.2 mm holes. We have a 3.2 mm holes. There is no annular ring, or if you want, you can have those. There are different varieties. You want to a stitched via, you will have a stitched via version. So we will choose the first one, 3.2 mm mounting hole, 3.2 mm. And yeah, if you want to see this thing is going to look like this. You can select this way also. You want pad, you want to have pad on top and bottom, or yeah, or in bottom. So this way, I'll just go for a plain, just a simple mounting hole, 3.2 mm. So just put at 4 corners. Right now I'm not aligning, but first go and not in schematic you put it. Otherwise, once you reload it, it will delete. So hit not in schematic. Done. So there is a best practice thing that you must use this thing actually, the mounting. Let us say for mounting hole, I want to draw just for the guidelines. I want to draw a line. Put it some silk screen layer and draw a rectangle. So that your all holes will be aligned, and make sure that, let us say if I want a hole at 90 and 140. So just 10 mm, 5 mm boundary I have from all the direction. So you can match this way. You can match the top and this thing 5 mm boundary. And there are many ways you can do this, but yeah, the simplest way would be to have a block. Make this 5 mm, 5 mm. So you have to match this guy here. So left side is aligned, top side I want to align. Okay, this is also done. Now it will take reference on this vertical left corner. So just make it 90 again and 140. So you will have all the direction 5 mm by 5 mm spacing. You understand what I'm saying? Anyone has doubt? It's all mechanical settings. Yeah, you can do this. You can use this measurement tool as well to do all your checks. Okay, so let us not go into much depth here. This thing comes from the practice, and now you have to align this into the center so that all holes will be perfectly aligned. I don't know what is the actual mounting this thing, but you have to just get those things from the CAD file, and you can feed it here. So now all my 4 holes are properly aligned between the 5 mm by 5 mm coordinate. From the edges, the hole is going to be center of the origin is going to be 5 mm away. Fine. Now you can delete this guy, not needed, or you can change this layer to user drawing, and that's all. User drawing, you can hide it. Someone is going to join. Yeah, Abin Anthony, ask the question. Any question here?
Sir, after mounting the hole, we missed this.
Which one?
After mounting the holes, you draw a screen and a rectangle. That one we missed.
Yeah. You see, this is you can just put 4 holes on 4 corners. But what I have drawn, why I have drawn that, because see, this way also you can do. You can make sure that your hole placement is down on precise location, 5 mm by 5 mm, 5 mm from the board edge. You understand what I'm saying? So to do that, there are multiple ways. What I have done, I have drawn a rectangle 5 mm away from the boundary, 5 mm, 5 mm. So this dimension is 150 horizontal length, vertical is 100, 150 by 100. So 5 mm, 5 mm from all the direction. If you do 10 mm will be the reduction. So 90 vertical height of this rectangle is going to be there, and 140 is going to be the horizontal length. So that I have done the alignment. There are multiple ways to do that. You can do a practice. Just draw it. Do you see this mechanical? I don't see any. Yeah, go ahead and ask any question if you have any specific question. You have to draw this rectangle. You ask the question how you can do that, or like, can you ask the question again clearly so that I can understand what is your, actual problem?
Sir, actually we missed that part. We were throwing this, trying to mount this mounting holes. That time we missed something.
I will cover again. Just go to user drawing. Select this rectangle. Draw a rectangle. Just put it here. Height, I want 90. 100 height minus 10. 5 you want to keep offset both the side, top and bottom. Similarly, in width wise, 150 it is there. We want to keep 5 mm offset. So 150 minus 5 that means 150 minus 10. It becomes 140. So this will be your dimension, correct? But since you want to place it in, how you will decide? It is 5 mm away from this boundary, vertical boundary, and 5 mm away from this horizontal boundary. So for that, you can draw another rectangle, and that you can keep 5 by 5, or wherever you want. See, right now I am drawing. I want to keep the corner 5 mm away, so that I am drawing this. But this can depend on your requirement. You understand what I'm saying? Did you got it?
Yes, sir. No.
So this is 5 mm away. This guy is not 5 mm away. Yeah, it is not 5 mm away. So here the key thing is to understand is you have to align the vertical, top left corner you have to align. That is the origin. That is not the origin. There is the origin. You can see here. You can see this thing X, Y. You can see. If you go left side, one second. Yes, if you go left side, there is your origin. Where is your origin? Your origin is this one. You understand this? You can move this origin here also. But I would recommend let us not do this. You just keep in mind that you have to always make alignment on vertical and left corner. So this corner you have to align. So for that you have to keep this precisely 5 mm away, and this guy is already 5 mm. So now since this is already having 10 mm offset, so 5 mm will be transferred to right side, and again, oh, it is not there. So what's the problem? This guy got increased. Let us make it 40. So now it will be there. Yeah, 5 mm. And bottom side you have the 5 mm. So you see it's all up to individual. The way I am doing it, this is not the fixed one. You can do your own tweak and explore, and you can find many other ways to do it. This is the simpler way I found to do. So I may be explaining that way. Now it is clear, or is there any question so far? Just go ahead if you have any question, ask.
So clear, sir.
Sure. So since this one we don't want to display, we'll just disable it. You want to put decoration, you can do that, but right now I'm not going to cover the decorative part of it. So I will just complete this routing first. So let us to route it. You might feel that this yellow color silk skins are confusing you. You might go and delete these things. Just select route. Where you want to route, bottom or top? Any answer? Guys, you be interactive. If I'm asking anything, please try to answer. Bottom. So I will just select the bottom, select the route tracks. I will select one track and I will just route it. Done. Start from here, click and drag to right side and drop it here. Once you click it, let us say once I click it, it is selected. You have to just drag your mouse. Now you see, if you move here and there, the segment is being formed accordingly. So what you have to do, where you feel the way you want to route is being advised by this tool, there you just click left. So again it is frozen. Okay, this segment is frozen. I want to freeze this segment. Yes, I want to freeze this segment. Okay, done. So now my routing is done here. Just hit escape so that you will run. You will go to select mode. In select mode, you can do all this adjustment and all. Similarly, again go to this route. Again do this routing. Guys, you do the routing, and the way I am doing, keep following me. We'll complete the first all the routing. Let us say who is completing first. Raise your hand if someone is completed. Again, I'm saying there are many rules to do this cap placement. I'm not following all those rules. I'm just doing simply a layout. Later we will cover all those things if you need. Done, guys? Suresh sir? Hello? How many people completed?
Just a minute, sir. They're going on.
Yeah. Just do a basic routing. So your all interconnects should be completed. I mean, all are connected. It should look like this, something like this.
Yes, sir. Yeah. We finished, sir.
Yeah, rest of the other people are also done?
Yes, sir. Yeah.
Guys, speak up. Yes or no?
Yes, sir. Yes, sir.
Okay. Okay. So now the thing is like how many nets are there? Can anyone answer? How many nets are there total? In this current view, I'm not saying whole schematic, current view.
The two nets, sir.
So totally two, one AC and another DC.
No. AC had two nets. One AC1, another is AC2.
Yes, yeah.
I'm saying to count all the nets. Please count all the nets and let me know.
Totally four.
Four? Seriously, four?
Sir, two for AC and output we have two.
Yeah. So two AC and rest of us. Just count and tell me. One number I need. I want to hear that good magic number.
DC1.
Okay, no problem. Yeah, go ahead. I want to hear one number. 1, 2, 3, 4, 5, 6. How many nets?
1, 2, 3, 4, sir, actually.
Great, sir. Anyone else? Any other answer?
Yes, one, yes, two, yes, one. This.
Yeah, I will give 20 seconds.
Yes, two. DC. I think both already 5 सुनेंगे.
DC out.
DC out. DC out कर देंगे. ಅದು DC தான். ಸ್ವಿಚ್ ಮಾರುದು. ಗ್ರೌಂಡ್ ಕಾಮನ್ ಆಗಿದೆ.
5, 10, 20 seconds is over. Now the answer I will give, sir. 5. Whoever was saying 5, I heard someone is saying 5. 5 is correct answer, Suresh, sir.
Yes, sir. Okay.
So 5 nets are there, sir. 2 AC and one is ground, which is going all the way from this rectifier till the connector, output connector of this thing. So this output 1 has the one ground, 2 AC input, 3, 1 DC input to the regulator, 1 DC output. So total 1, 2, 3, 4 and 5. So total 5 nets we have. Now there is a catch. You can do a plane filling. You can do a copper core here itself. You don't need to route. You have completed basic thing. Now you put just a copper pore that will take care of everything. So one ground copper pore we can do from here to here. Am I right?
Yeah.
One DC input pore we can do from here to here. Are you able to see my cursor?
Yes, yeah.
One output you can do from here to all the way till the output connector. So 3 copper pores are going to be there. And there are 2 here also. You can do copper pore or you can just feed the input, AC input. So now we'll do copper pore later, but let us do one thing first. Just go to the net, hit left click, and in keyboard you press U 2 times.
U 2 times.
U 2 times you have to press. So now you see it is highlighted into little white color. If everyone see this, please let me know. Yes, you tell, please tell yes, so that I will proceed.
Yes, sir.
Yes, sir, proceed.
Now you hit E for elephant in your keyboard.
Yes, shortcut. Yeah.
Shortcut. No, I'm just teaching the shortcut. Yeah, just remember the shortcut because yeah, this is going to be numerous time going to be used. Now just hit 1 mm and hit OK. Again, if you're not satisfied, 2 mm, 2.54. It is in mm. 2.54 mm means how many mils? 100 mils. 2.54 mm means 100 mils. This is going to be 100 mils stress.
I don't like language.
You can keep it. Whatever. See, you have to see. That's what I've said. We are drawing just a test schematic. It's not the electrical specs are not here. If you have a electrical spec, we'll follow the precise this thing. I am teaching what are the options available, how to use them, what are the tools available, features available. So just again hit you keep doing, you route all those things with like I said 2.54.
Sir, you can tell in mills only, sir.
You can go mills also, sir. There is no hard and fixed thing.
Mills, it is okay, sir. Because we use.
No. See, as a CAD engineer, you should be familiar with everything. You should be very familiar with familiar with mills, because this unit does not make any difference. For me, it is both are same. I see both are equally.
Okay.
Go ahead. You want in mills, we can change that. I think we will cover that part later. But in the scale, if you give you a scale, just instrument box or a scale irko na, on the scale or any scale, if you see, you have the inch one side, another side you have the mm. So it is very easy to measure the mm. I think okay, fine. It's all up to personal preference. We can go in mills and mm also. Okay, let us follow whatever I'm suggesting first. We'll cover to that part. I think you're right. Maybe we can cover in mills also. See, whenever I selected this one and double 2 times when I hit U, it got automatically highlighted. Double time U means 1 time U means it will highlight only that particular segment. You understand what I'm saying? Point 1 to point 2. And 2 times U means it will highlight the entire net in that schematic. And then you hit E, make it 2.54 or whatever you want, you can make it. But make sure that there should not be short circuit between these two. You should not make enough thickness so that these two get short circuited. See, here there is a problem. You see that, no? Are you guys able to see this problem?
Yes, sir. Yeah.
So maybe this segment alone, you make it 2. Yeah. Okay, done. You should be very careful. This clearance you should not kill. Otherwise, that's all. Things are gone. They will, while soldering the production, the people will face this problem. Everyone is clear till this stage?
Yes, sir. Yeah, clear.
So let us complete till here whatever so far what we have done, and again then I will cover the next part. Yes, double panna full up, and then hit E, make it 2.54. So this connector is good. There is a good spacing maintained here. This capacitor is spacing is clearance is getting in problem. Maybe we can just do a small tweaks to this guys so that this problem is gone. Yes, let us have this way. So that idea is first current should not go. Okay, let us not follow the electrical this thing. Yeah, if you go in more depth, it becomes even more this thing sensitive. If you do a right, see the routing is a key actually. If you do a right routing, you will have very less noise in your output. If you do a wrong routing, wrong placement and wrong routing, you will have too much noise in your output. Finally, you will end up in debugging those noise. You will be blaming the regulator, you will be blaming n number of things. But actually, this layout also contributes to the noise and all. And if you put a full load condition, that time if your regulator is not placed properly, maybe this will not do decoupling and filtering in an efficient way. So it should not take output from here and put a very big loop inductance to the capacitor leads. That will be a problem. Okay, let us not go to that technical thing. Let's complete this. Done? Suresh sir?
Yes, sir. Yeah.
Once things are done.
Yes, sir. 1% done, sir.
Everyone has completed this?
Yes, sir. Yeah.
Yes, sir.
So now Now, okay, fine. Now it is so done. I will go to one thing. We'll go to okay. We'll enable the silk screen, and we will come to the silk screen so that we can see this. I think, is it okay? The text. This is very minimum text. If you see this text, it will look very small, 1 mm, 1 mm, and 1.5 mm. So what we will do, if you do one by one, you can make it let us say 2 mm or 1.8 mm or 2 mm. 1 mm is minimum visible text, but you should have some enough size so that user can, or whoever is installing those components, or even technician debugging, it should be easy. So let us keep 1 point more than 1.5. Or you can keep 2 also. It's all up to like what you want to fix. I mean, how much you want to keep it. So this much text should be enough to read. Correct, sir?
Yes. Yeah.
If let us say if you're not confident here, you can go in the 3D view and you can keep this thing into the, like, this is what is going to be the actual size. So see, this you are able to read it clearly, but this thing may not be able to read clearly. So let us keep this dimension. So to do that, go to view. Go to where it is. Yes, here it is. Go to edit. Yes, edit. Go to edit and edit the edit text and graphics property. This option you have to go, and here you want to only change the reference designator, and reference designator you want to make text width for the top layer. You want to change the text width to 1.8. This also you want to make 1.8, and thickness you want to make 0.22 or 25 or 2, whatever you want to 54, or let us make it 22. Okay. Once you apply it, you should be able to see all the reference designator they have got updated in one shot. Just give them the right position so that they should look clean. D1, D3, D2, D4, C4. It's not, yeah, the only the convention is you should keep in such a way that it should be easy to read for the people. Let us say if I keep here, and in future if you put a heat sink, that you won't be visible. Let us keep U1 somewhere so that it should be visible in the front side of the regulator, so that definitely heatsink is not going to be mounted here, it's going to be mounted here only, so people will be able to read this U1. C5, let us keep here, and J2. Done. Everyone is done till this stage? Shall you go ahead?
Yeah, done, sir.
If you are done, you can have a view in 3D view, and you can make sure that things are okay for you. Is it okay, sir?
Yes, sir. Okay, this one is okay.
Sure. Now what we can do, you can select, now you can do modular. The beauty of having modular design is you can just go to rectifier, select one, D1, go to a layout. This is your D1. Select D1, and how you can do that? You can go to replicate layout. There is something also called replicate layout. Just hit there, so it will select all the layouts which is in that particular block. So in that block we have 4 diodes, we have 1 capacitor, and this is the routing. Everything is selected here. You have to replicate it. I don't know where the window is gone. Okay. So this feature is replicate layout feature. Let me skip from here. It's not going away. See, this has some bugs also, so let us not confuse with that. I'm just trying to. Okay, this is fine. We're going to this guy. Why this layout is selected? Okay. I don't know. It's not going away. Anyway, we'll go to schematic and we'll try to make sure that okay, it got stuck. Anyway, doesn't matter. We'll save this schematic and this layout, and we'll close this guy. Again, we'll come back. Come back to the project. We'll try to open this guy, and it should open our schematic. Now our schematic is open. Hit on replicate layout. Select one guy, this thing. Hit on replicate layout, and this window should open. Earlier, this window was not opening. Did you see the bug now? What was the bug? Suresh sir?
Yes, sir. Yeah.
So the bug was this window was not opening.
Just a minute, sir. Not opening.
This window, is it opening for you?
Yes, sir. Yeah, now opening.
This window?
Yeah, yes, sir. Yeah, correct.
Small window.
Yes, it's opening.
Yeah, opening means you want to replicate. So the block we have created, schematic we have drawn, layout also you can just duplicate.
Just a minute, sir. One more time. This window, small window. Yeah.
Small window, are you able to see or not?
Yeah, I'm seeing, but one more time, sir.
One more time, I should repeat the process.
Yeah,
okay.
Yeah.
So I just close this. You just select one component from your block. Which block? The block, the rectifier block. One component. What are the components? D1, D2, D3, D4, and C1. Where? Inside this first block. Yeah. See, this routing we have completed. This connector, rectifier, regulator, and connector 2, output connector. This routing we have completed. We don't want to reroute this. Just want to ditto apply the same routing to all this. So you just go to this block. We'll select one component, not here, in the schematic. So you'll go and select D1. Sorry, in the layout. You go in D1, hit on replicate layout. So it should open the window. Now that window is gone. So where it is gone? You have to find where the window is gone.
Sir, one doubt.
Yeah, go ahead.
First, we want to select the schematic D1, and we want to select the routing setup.
No. First, go to layout. See, it is again stuck. Let me close. See that window is already open somewhere, but that is not showing up. No problem. Just close that. Save, close, again reopen. Select. See, again I will repeat.
Yes.
Select the component. One component, not all component. That component is going to be the origin. Origin. When it is origin, I say select the first component which is at the corner. So these are my components which is there inside that block. Am I right?
Yeah.
4 diodes and 1 capacitor. Rectifier section. And this section is my regulator section. Am I right?
Yes, sir.
Maybe for your convenient, I can draw this thing. This is my regulator section, sir. Rectifier section. Correct?
Yeah, sir.
And this is my regulator section. Done?
Yes, sir.
Is it now clear? Okay. So I will select any component from this block. I will go to replicate layout. And once the window is open and the window is gone. Where it is there, I have not connected any other keys. Okay. Let me refresh it. Let me deselect from here. It should be clean. It should not be, you should not have selected anything else apart from that component. Otherwise it will mess up. So this is a plugin you have to install. Once you install, you have to select D1, go and hit this guy, and you will see this, where it is. Are you guys able to see that? Window. I'm not able to see.
So should we install a plugin to
yeah, you have to install that plugin. Where it should be? No problem. We'll do one thing. We'll save it. We'll close these things. We will reopen this thing actually. We'll reopen the tool. You have to install that plugin. If you don't find, that's why I asked you. Are you able to see that window?
No, sir. We have.
If you're not able to see, no problem. Just do the routing, usual routing for all the three, and then that will be done. I think you have to make it small so that it should not be, because 3 sections you have to accommodate on the same board. So it should be small enough. It should be, yeah, it should be kind of. So now I have to select D1, go to replicate, and I think that where that is going. I'm having only one PC screen only. Where that is going? Okay, fine. So I'm trying to explain one feature of this tool, plugin, but that plugin is not working right now. Maybe you can ignore that. Similarly, what you can do, you can place all the components one by one, same way, and yeah. Let us try this guy. Why it is selecting that one? Okay. There is some bug in this tool, so let us be aware about that.
What is the name of the plugin?
See, you have to go to this guy, this plugin and content manager. Yeah, and let us install that. That is called PCB. One second, let me give you the right name. That is called okay. Oh, since one window is open, it does not allow other window to be open. Okay. That is called replicate layout. Replicate layout. Now go to plugin manager, and here you have to type the replicate layout, which is already installed. If you don't have, you can install it. Are you guys done with this? Install this one.
Yes, sir. Now going on.
Yeah, please install all those. So it should come under installed. If you go to your installed version, you should see how many plugins you have installed. So out of your all plugins, this replicate layout should be there. See, this tool has many bugs actually, but when you will encounter that bug, for basic work there is no bug. When you try to use its advanced features, you might encounter some of the bugs. So you have to be aware about all those. I have deselected. See, I have deselected those components, but still it is in selected mode, or it is highlighted mode. Okay. Let's not go there. I think I should clear the cache. Whenever you encounter any such problem, make sure that you delete your cache. Let me open again. Schematic is opened. Layout is opened. Select one component, then hit this window. That's all. It's not working. Wait, it's not working. Is there any error? No. You don't see any error. Okay. It's somewhere else. Okay. See, that plugin is not working right now. Let us not waste time there. Yeah, let us not waste time there. Let us do the routing for all this thing. Yeah, no problem. Let us not rely on the layout replication. Let us do all the routing manually. So what we'll do, we'll go and select the second lot. Second lot is where? Second lot is here. So just select this thing. It got highlighted. Go to the layout, just drag it, bring inside. So just to make it easy, you can go 5, 6, 7, 8, and 2, 5. Okay, 5, 6, 7, 8. Layout replication we'll see later why it is not working. I think you should not rely on the plugins. Plugins are just there to make the work easy, but you should not rely on those, because that might not work all the time. So we should be very expert in. Now I'm doing the placement of my second regulation section. Anyone has any question so far?
No, sir.
Just do it, whatever I'm doing. So second and third placement is practice for you. Oh, that is outside. Now here comes this thing, challenging part. Not challenging part. This might give you criss-cross feeling, but let us not confuse with that. This is input. It has to go here, and this is another thing. Okay, so we'll do this way. So we have to make sure that there should not be any criss-cross happening. So the idea is always take the input from the connector. You understand what I'm saying? Let us not take input from the in-between or from these diodes. Otherwise, you will be loading these traces. They will have the common mode noise. Okay, fine. Not confused with that one. Double click view. Suresh sir?
Yes, sir.
Is it going good from your end?
Yes, sir. Going on. Okay, no problem.
Yeah. Complete the routing, sir. This routing. Suresh sir.
Yes, sir.
How is the progress at your end?
Yes, Justin sir, now going on. A little bit time we will finish one.
Yeah, finish sir. Finish and tell me it is done.
Yeah.
So we'll complete the Gerber stage. We'll create the Gerber file for this, and we'll try to import on any of our like online websites, and we'll see how it is looking. We'll review the layout, and then we will wind up the class.
Yes, sir. Okay.
For today.
Yes, sir. Okay.
Other things to cover, but yeah, in one shot, let us not burden too much. I will give a task, and maybe all staffs has to practice, and they have to come up with some their own innovation in the next classes. So done. So anyone has any question? Please ask, guys. If you're stuck, or if you need any support, or if you have any question, please ask. Suresh sir, how is the progress of your team? Everyone is going good, or there is any problem?
No problem, sir. Is going on. Not yet in finished it. Just maybe we need for some time.
Yeah. Go ahead. I'm here only. I'm rearranging the footprint, sir, after routing is completed. Sorry, rearranging the silk skin agents, and that is also completed. You want, you can put some decorations. Right now, there is no footprint for this guy. I mean, this footprint is not showing the 3D view. I mean, step file is not assigned to this footprint, so you're not able to see the connector component here because there is no 3D symbol assigned for this guy. So next thing is, sir, to download the there are many other things which right now I think we are going to skip that part for today, but maybe I will there is no 3D, so I will what we will do, we'll download one 3D step file, one model for this phonics connector from Mouser, and we'll assign. Maybe I will ping this link into our chat box. So please go to this Mouser and download this step file from here, 3D. Once you hit download, I think I have account so that I can download. Maybe I will tell without account from where you can download. Everywhere you will need actually account. Or maybe
account means Mouser account, na?
Yeah, if you have Mouser account, you please download this thing and share to everybody. Or maybe I will let me search. Someone might have connector 5mm dot, because what we need is, we don't want to create any Mouser account. GrabCAD, this all guys, they need all, they wherever I think you'll go, you will need one what I say, this thing. Definitely you need that login, this thing, credential. Otherwise, without login credential, you cannot download it. See, this is what we need. This is called 3D model. You can download 3D model, but here you need a login account. This is some query, yeah. So they might already have terminal phonic box. So in the library, I think it should be already there. Let me search. So to check in the library, you have to go to footprint editor, and there you have to type just phonics. This is the 5.08 for 2 pin. If you want to see 3D, view 3D, whether there is a symbol. Yeah, there is a symbol already there, correct? So we need not to download. We have our this thing already has. What we will do, we will rename. We will do one thing. We will reassign this thing. I will ping into the chat box the name so that you can easily copy and paste there. So guys, use this phonics connector. We are going to reassign the phonics connector.
Yes, sir, we got it, sir, the connector.
Sure. So if you got it there, what you do, sir, please go to your schematic, and all these terminals, you update that.
Yes,
footprint, sir. Just go to footprint, paste it here, select it, see the 3D view. That connector should be showing up like this. Showing, just replace it. I think someone asked this question at the beginning itself. Sir, if we do for one, do we need to do for all? Yes, sir, you do. You need to do for all. Then you have to hit yes. So only the J1 is replaced. Now you have to replace all these things. So you have to go and change all these things. Yes, J2, J3. So you have to replace for all. Okay, whoever has not completed the routing, let us come to this part, because routing is one thing. Let us come to this part. Let us complete the placement and come to this section. The routing you will complete later. Now it is all done. How can we change this into our layout? Is you have to just go to tools. First you have to select this home directory. You have to go to tools, update PC from schematic. Should be all delete previous one and replace with new one. Update, and those all will be replaced. So now if you go to 3D view, you should see the connectors. Are you able to see the connectors, sir?
Yes, sir.
Yeah. So one key thing is, this guy has opposite assignment. See, wire has to be entered this side. That is wrong. You understand what I'm saying now? Screw mounting is not correct for this one, for input. If no one can insert wire from this side. It should come, a wire hole should come this side. Am I right?
Yes, yeah, correct.
Which is wrong. For all this guys, it is correct. For this guy, it is wrong. So what we will do, we'll go to our input connector. here, the schematic. We'll just select this transform section, mirror vertical, and that's all. Done. We'll swap this thing and update to the schematic. So now we have to come here. You have to rotate it and you have to keep it at the same place. Now you can keep it even, I think here it's fine. It's not been a problem. You have to make sure that connections are intact. They should not, connectors should not break. Yeah, they are correct. Done?
Yeah, yes, sir, done.
Now if you see your board should look like this. You have to feed the AC input here and you have to take the DC output from here. 3 DC output from the same transformer. Or you can have 3 inputs also. Okay, fine. So the board completes here, but the decorative part of it we have not covered. If you want to cover the decoration, see this thing has gone. This legend text size has gone reduced, because while import it goes to 1 mm height and width. So how to fix that? You have to go to edit text and graphics. You have to make text width 1.8. That's what I think we have followed. Rest all 1.8, and this was 0.22. Thickness and all reference designator you have to reset. So now come to the correct place. So now we keep it here, J2, J3, J4. Everyone done, sir?
Yeah, yes, sir. Yeah, finished it.
So now what we can do, sir, you have to go to silk screen, and now if you have installed this one, it's called create labels. It will look good. That's all. You can put what is positive, what is negative, where is the AC, where is the DC. For those, this thing is there. Now I'm going to put a label called AC.
Symbol.
Yeah. AC1. I'm going to put it here. Let us put here wherever you want. AC1.
Symbol.
It's not symbol, sir. It's this is called create labels.
Oh, label.
Yeah, label. So this is AC2. If you don't have this plugin, you can download from there. You can just type create label. Create labels. You have to go here. You have to assign this thing. You can call it as a plus 5 volt, and you can call this one as a ground. All right, sir. Now this is looking clear.
Yeah, sir.
So
this one is a silk screen.
Silk screen, sir. You have to do all work in silk screen. You have to select your silk screen and you have to do all work in silk screen.
Okay.
So now I'm doing the decorative part of it. All electrical routing, everything is all done. Now decoration is going on. If you don't do decoration, no matter how well you have designed the layout, it won't look good. And it's not only decoration, it helps in understanding the sections, debugging, many things, many aspects it helps. So now if you see this board, it will look like something like this. Done, sir, everyone?
Yeah, yes, sir, yeah.
You can delete these references if you don't want, because this will come as a part of silk screen. Wherever you have these references, you can delete. Now it will look clean. And if you want to put some more text here, just take this one and make this guy big if you want. Size you may make it 3, and yeah, how it is looking. Okay, you can
how is this symbol coming?
Now it is
you have some symbols right here.
Where?
This arrow like symbol. I got this text, bigger text, but this
arrow like symbol you can change from here.
Cap right.
Yeah, cap right. Yes. Regulator 1 or just reg 1. You can see, you can increase the spacing. You can see that, no, how I am increasing the spacing left and right. This is all the decorative part. I'm saying again I'm saying it's a decorative part of it. If you don't do it right, no matter how much effort you have put, your PCB will look, I mean, look wise it won't be like that convenient. I mean, it might work, but ultimately if it is yeah, see, the electrical things are more important than this, but yeah, this helps in all. I said no, debugging and other troubleshooting, and even the panel mounting and other things becomes easy if you have these things there. So now the 2-day session completes here. We have completed the 3 rectifier regulator design board we have designed, and there are different ways to view this. Everyone has completed this, or is there any question?
Completed, sir.
Suresh sir?
Yes, sir. Yeah.
Now tell me, sir, what we should do now.
Yes, sir. This is okay for us. So maybe after lunch, are you free, sir?
Maybe after lunch I have some other plans, sir. So maybe we can meet some other day, sir. Maybe tomorrow, if you guys are free.
Okay, online. This is okay, sir. No issue. Tomorrow, just off day.
Yeah, whenever you have. I think morning session I will be free.
Yes, sir. Morning 10 to.
Morning same time. Maybe we can meet similar timings.
Yeah, 10 to 1. Is okay for.
Yeah.
Yeah, tomorrow our plan is maybe we need for symbol creation and as well as for.
Yeah. So far. So here our layout completes. If you want to review backside of routing,
yeah,
you can just do this, and you can backside mask it will look like this. So wherever you see yellow color, that is the soldering spot. You have to put the soldering. Those are the masks open for soldering. But if you want to see the routing, you can remove the mask. There is no mask. So now everything is exposed. Exposed means you're able to see the routing, actual routing, the copper which is bottom side. Can everyone show this thing, or whoever has completed well, they can show their progress?
Just
so that we can record. Maybe you can present it.
How I can show, sir?
Yeah, so you can go to the. Yeah, I will tell that. You can go here and you can use this button, sir.
Yes. Can I show?
Yeah, go ahead, sir. Go ahead. Put it there.
Just.
I will stop my sharing.
Yeah.
Please go ahead and present, sir.
Just a minute, sir.
Yeah, you can minimize this window. Yeah. Super.
But alignment is not finished.
No issue. I think, yeah, maybe you have not done those legend and other things also. But yeah, this is well. Yeah, there is a there is a space violation, sir.
Yes, sir. Yeah.
Yeah, those space violations you should be careful. Yeah, spacing and all.
Yes, sir. Maybe maybe more time we are creating for this one. Maybe avoiding for this error, I think.
Yeah, if you'll have the practice, I think you'll be able to do this. Very good. Yeah, very nice. So now I think you have at least a basic grip on the tool. Later, I think you can explore more. So I would expect, sir, in the next session, everyone will be what board you will be interested, sir, to design? Let us take one real-time board and give this assignment to everyone so that over the night everyone will be designing. Let us take some simple board, simple example.
Okay.
So which example you please discuss with the team, or I would like all other people to give feedback.
Okay, sir. Okay, we will do an afternoon section. So maybe
No. What board we are going to do? That's what I think the assignment, overnight assignment. I mean, second half we are not going to have the session. So second half people will be working and they will be doing some board.
Just a minute, sir. We have for some list of work. I will show now.
Yeah, go ahead, sir.
LED flashing, na? Using tool AC. LED chasing. So LED chasing.
Okay.
So already this is one of the major project for the diploma students. So we will practice on LED chasing.
Okay, sir. Okay. So
using tool AC.
So how is the circuit going to look like? Do you have any schematic, sir? Rough schematic. So everyone will take the note of it.
Yes. Just a minute.
So whoever is working, guys, please take a screenshot of the schematic.
Yeah.
And just
a minute. Just a minute, I will show the circuit. Schematic.
Sure. Yeah, please show the circuit. So we all will take this snippet of it, and tomorrow morning we will meet with a layout. Everyone should be having the layout completed.
Yeah, this one, sir.
Okay.
This is AC.
Yeah, could you please take a screenshot, sir? Screenshot, and you can share in the chat box.
Yeah.
Or you can share through WhatsApp at least to everyone. Create a group and share to all the people. Yes, now, yeah, this is recorded in our session.
Yeah.
So everyone will try to make this